Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydration of an alkene, acid catalyzed or via oxymercuration, adds water across AC is equal to C double bond. For an alcohol to be prepared by hydration of an alkene, there must exist an alkene such that addition of water, following Markovnikov's rule or anti-Markovnikov, gives that alcohol. This requires that the carbon-bearing diol group must have been part of AC is equal to C double bond, meaning it must have had at least one hydrogen on it or the adjacent carbon must have had a hydrogen. Essentially, the carbon-bearing or the adjacent carbon must be able to form a double bond. Moving on to the next step. Analyze option A. Pentane 1-ol CH3CH to CH to CH to CH2O. The O is on C1. This could be prepared by hydroboration oxidation, anti-Markovnikov hydration of Pent 1Na. So this can be prepared. Moving on to the next step. Analyze option B. 2-ethylbutane 1-ol. The O is on a primary carbon, C1, with the adjacent carbon, C2, bearing an ethyl group and a hydrogen. Since C2 has a hydrogen, a double bond between C1 and C2 is possible. 2-ethyl but 1Na exists, and anti-Markovnikov hydration, hydroboration oxidation, would give this alcohol. So this can be prepared. And for the final step, analyze option C. 4-methylpentane 1-ol. O is on C1 of a chain with a methyl branch at C4. The adjacent carbon, C2, has hydrogens, so AC1 is equal to C2 double bond, 4-methylpent 1Na exists. Anti-Markovnikov hydration gives this primary alcohol. So this can be prepared. Analyze option D. 2,2-dimethylpropane 1-ol neopentyl alcohol CH3, 3C, CH2O. The O is on C1, primary carbon. The adjacent carbon C2 is a quaternary carbon bearing 3 methyl groups and no hydrogen. For hydration of an alkene to give this alcohol, we would need a double bond at C1 is equal to C2. However, C2 has no hydrogen, so it cannot form a double bond, no H to remove to generate the alkene via elimination, and neopentyl system has no viable alkene precursor that would give a primary O at C1 without rearrangement. The alkene that would need to exist is CH3, 3C is equal to CH2, 3,3-dimethyl but 1Na. Wait, that is actually 2-methyl but 1Na analog. Actually, the required alkene would be CH3 to C is equal to CH2 with an extra methyl, i.e., 2,2-dimethylprop 1Na. But that compound does not exist as the carbon would be pentavalent. In fact, neopentyl alcohol requires C, CH3, 3CH2O. The C2 is C, CH3, 3, a quaternary carbon with no H. So no alkene C1 is equal to C2 can be formed. Any other alkene hydration would not give O at the neopentyl position due to rearrangements. Therefore, 2,2-dimethylpropane 1-ol cannot be prepared by simple hydration of an alkene. Therefore, the correct answer is D. Therefore, the correct answer is option D.